Right, we've got some ratio to start with. We're asked to simplify P to Q, but we are told that Q is actually equal to 5P. And so I can replace Q by 5P, and I can write it like this. But it's not in its simplest form now. I've got a common factor of P. So what I can do, just like if I have 2 to 4, I can divide through by 2 and make it 1 to 2. Well, if I had, I don't know, 2p to 4p, I could divide through by p, and I could just get rid of it and change it to 2 to 4. So I can do the same thing here. I can divide through by p, and I'm actually going to get 1 to 5 as my ratio. Now, if that's a little bit algebraic for you, you're not happy with that, then you could perhaps let's p equal a value. So let's p equal 1. Then q would equal 5 times p. It would be 5. And I'd get the same answer. So it feels a bit cheating because I don't know that p is equal to 1, but whatever the value actually is, it would cancel down. Like if p was 2, q would be 10, it would still cancel down to 1 to 5. So it's okay to use this approach, I think, as long as you kind of understand what's going on. We're then asked to work out the two different possible sets of angles for the isosceles triangle. Yeah, I've kind of glossed over that so far, but P is an interior angle of an isosceles triangle. Well, step one is let's work out what P is. And we know that when we add P and Q together, they're on a straight line, so it's equal to 180 degrees. This is in fact a fact for any interior and exterior angle pair on a polygon. They will add to give 180 degrees. In our case, we've got P plus 5P, because that's what Q is equal to, is going to equal 180. So 6P is equal to 180, and therefore P is equal to 30. And by the way, that means that, I'm just going to put this in brackets, Q would equal 150, and that's actually another way that you could do part A, because you could write the ratio as 30 to 150, which would cancel down to 150. Okay, we don't actually need it, so actually I'm going to get rid of it. So now I'm interested in different isosceles triangles that can occur. So what could happen? Well, we could get a triangle like this, where this is 30, and maybe these two sides are the same as well, and so that angle is going to be 30 degrees. I'm just going to go with it. I didn't kind of intend to finish the whole triangle off, but I've made those two sides the same. These two add to 60, so 180 minus 60 means that this is going to be 120 degrees. So I've got my first answer, 30, 30, and 120 degrees. That's the case when two angles are 30. We're going to get another case, and I don't think this one's going to be drawn accurately this time, but what about if these two sides are equal? So now I don't have the 30 degrees. I've got that these two are equal. Now they don't look equal, but that's because I've not drawn it accurately. I can work these out because I can do 180 minus 30, which is 150. So I know that the two of them add to 150, but they are the same. So I divide it by 2, and they're going to be 75 each of them. Okay, and that's going to be, I probably should have done it all in green, but anyway, that's going to give me 30 degrees, 75 degrees, and 75 degrees. Now, you might be thinking, there's one other way you could have drawn that. You could have drawn a triangle where this is 30. Instead of the top two being equal, or the top and the bottom, what about if this one and this one were equal? But that's going to give me the same answer again, because in that case, these two sides are equal, so this would also be 30, and it'll be just a slightly different version of the first case that I saw. So actually, there's only two distinct cases. I don't need to worry about this one. I've got my answers there.